The Orford Ness Rotating Wireless Beacon was built by the Royal Aircraft Establishment, or RAE, on Orford Ness in 1928. It was renamed Black Beacon by the National Trust when it purchased most of Orford Ness from the UK's Ministry of Defence in 1993, and for simplicity here, we will use the term Black Beacon. No engineering drawings of the Black Beacon have been found, so photographs and site surveys have been used to create the dimensionally correct images used in this video. When it was built, equipment was moved over shingle tracks and a narrow-gauge railway. The characters shown in this presentation represent people in an early 1930s photograph. Black Beacon remains, and English Heritage designated it a listed building in 2014. Black Beacon and its associated electrical powerhouse were the first military research structures built on the shingle between the North Sea coastline and Stony Ditch. Although its structure and windmill-like profile are retained, it has undergone several minor structural changes, including the addition of an external staircase, added sometime before 1958. The Orford Ness lighthouse, seen in the background, was built in 1792, but, due to coastal erosion, it was decommissioned in 2013 and demolished in 2020. This cross-section shows that Black Beacon comprised 2 floors, with no evidence having been found to show internal or external stairs in 1929. Black Beacon consisted of a rotating radio transmitting aerial and associated transmitting and control systems, all contained within an 11.3-meter high octagonal-shaped wooden tower. This experimental radio direction finding (RDF) system was announced in 1928 as an aid to maritime shipping, but was actually seen as more relevant to aviation. The RDF experiments carried out, which could provide an observer's compass bearing, were later paired with a similar beacon built near RAE Farnborough in 1929, but by using triangulation to provide the observer's location. Although this RDF technology had proven successful, it was stopped in 1934, and Black Beacon then became redundant. After being used as a storeroom, it later became part of the telemetry system used in the many bomb ballistic trials that took place on the Ness. The concrete ground floor contained the power system required for the RDF hardware, located on the floor above, to produce the continuous wave radio signal and power circuits that accurately rotated the 10-foot square by 2 feet deep, rectangular wooden frame, which supported the copper transmitting loop. The rotating wooden frame also housed the air tuning condenser required for the radio oscillations production. The metal base contained power rectifying valves that provided power via slip rings for the signal's generation, and a tuning fork-controlled, phonic motor system that rotated the frame about its vertical axis at precisely 1 revolution per 60 seconds. The signal strength transmitted from the coil, or loop shown in red, varies for each face of the loop, shown here in blue, and this polar diagram illustrates the typical figure of 8 pattern of signal of strength transmitted from the loop aerial. In this example, the maximum strength signal is transmitted from the 2 ends of the loop toward the northern and southern directions, and the minimum strength from the 2 sides or planes towards the eastern and western directions. The transmitting loop rotates at exactly 360 degrees per minute, i.e. 6 degrees per second, and signal intensity received by a distant observer will vary as the figure of 8 profile rotates. The rotating loop allows an observer to determine his bearing from the transmitting beacon by simply using a stopwatch to record the time elapsed between 2 key events. Using standard radio receiving equipment and headphones, the observer would hear a warning sequence before being required to start a stopwatch exactly when the Morse character V was heard. The stopwatch then has to be stopped exactly at the time the observer hears the signal intensity fall to 0. The number of seconds that has elapsed between these 2 events has then to be multiplied by 6 to give the compass bearing from the beacon's known location. More detailed information about the rotating wireless beacons and their operation at Orford Ness and Farnborough will be found in a later ONMR 23 video.